Welcome to Tech Teach.
So first of all, we will be looking at out few points about the memory basics. So in the memory, memory locations and addresses, how we basically define. So how the memory of a computer is organized. The memory consists of many millions of storage cells, each of which can store a bit of information having the values 0 and 1. So memories are stored in the form of zeros and ones, and each bit storing each of the bits is having different cells, memory cells. So it's like, suppose we are having a memory cell. So memory, the basic memories are like the flip-flops. Flip-flops are considered to be the basic memories. So one flip-flop stores 1 bit of information. If we are having 10 flip-flops together or 8 flip-flops together, it will like 8-bit information. 8-bit we can store. So it has 8 flip-flops. It is equivalent to like 1 register. 1 register. It can have a 1 register. Combination of 8 flip-flops can become combined together to form 1 register. 1 register will be storing 8 bit of information. Similarly, suppose we want to store a larger data, we require lots of flip-flops or lots of storage cells. That is called like millions of the storage cells will be required to store the values. Usually bits are accessed in group of fixed size. So bits will be accessed in the group of fixed size like a byte. Okay. It could be like a byte, or it could be in the group of like 16-bit, 32-bit, likewise. So each group of n bit is referred to as a word of information, and n is called the word length. So if a processor is there, that is of 32-bit processor, so it is said like it will be doing, it will be accessing 32-bit at one time. So it is considered like here the word size will be 32-bit. So one word here will be 32-bit. So here, if n bits are referred to as the word of information, so word is like 32 bits, so n is 32, then 32 bit will be the word length or word size. So in modern computers have word length that typically range from 16 to 64. So modern computers have word length up to 64-bit. So 32 or 64-bit nowadays that are basically their processors into other memory. Okay. So how the memories are look like? So there is a memory. So into this memory there will be different address locations. So there is a first word will be stored here. This is, and it will be having an address. So first word will be stored and there will be an address. Second word and there will be an address. Likewise, there will be different memory locations that will be storing a particular word, and it will be having, there will be an address will be there, and each word will be of n bit. So this box is going to have basically n bit, and bit size will be there. So accessing the memory to store or retrieve a single item of information, either a word or a byte, requires distinct names or addresses for each location. So if you want to access a data from this location, then you should be knowing the address of this location. Address we should be knowing. So the memory can have up to 2 to the power k addressable locations with k addressing lines. So if any memory is there, so memory is basically represented by like 2 to the power k cross n. So this k indicates the address lines, and n indicates the data lines. So if k is the address lines in the sense, this is the memory. Address lines in the sense, there will be lines. If suppose these lines are 10, so k is equals to 10. It's meaning 2 to the power 10 memory locations are there here into here. Okay, and each memory location is having an address that is represented by 10 bits. Okay, suppose if k is equals to 2, if k is equals to 2 means 2 is the address line. So there is a memory and 2 is the address line. So with the 2 bit, 2 to the power 2 means 4 combinations of 2 bits will be there. So 0, 0, 0, 1, 1, 0, 1, 1. So for 0, 0, there will be a memory location. For 0, there will be a memory location. For 1, 0, there will be a memory location. Of 1, 1, there will be a memory location. At this memory location, whatever the data is stored, that will be in n bit format. If it is n, so n bit is here. Suppose n is equals to 4. So 4 bit data can be anything. 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. So 4 bit data is stored here. So n will be the 4 bit, k will be 2 bit. So the memory size will be 2 to the power 2 cross 4, that many bits. So its meaning is 2 to the power 2 is 4. So 4 locations are there and each location is storing 4 bit. So total 16 bit is the information that is stored by this memory. And each memory location will be having an address that will be of 2 bit address, because k was 2. So k is 2, so 2 bit address. Similarly here k is 10. So each address will be of 10 bit. So each memory location has its unique address that will be decided based on the address lines. So suppose the address line is of 16 bit. So it has 2 to the power 16 means 65536 memory locations. It has that many memory locations. That many memory locations. And if suppose each memory location is storing 1 bit of information, if each is memory location is storing 1 bit of information, so total this many bits of data is there. That means 64 kilobits is the data. Similarly, if the address lines are 20 bits, and 2 to the power 20 means that many address locations are there, that many memory locations are there, and each location is storing 1 bit information. So it will be that many bits. So here 1024 KB or 1 MB we can call it. So this is how the memories are basically represented. So memory locations, you can think of it here. If 32-bit is the size of one memory location, so this is the one memory location. This is one memory location. That is of 32-bit, n is equals to 32. So this will be B0, B1, B2, B3, likewise up to B30, B31. So this is like the MSB, and this will be the LSB. Least significant bit, most significant bit. So this is like the format in bit format represents. The same can be represented in byte format. So 8 bit can be combined together to represent 1 byte, 2 byte, 3 byte, 4 byte. Likewise, it can be storing. So this is how the memory locations have the data. Okay. One more thing, that is byte addressable. So what is a byte addressable meaning? So byte addressable in the sense, if any data is represented in the form of word, like this is having 32 bit or 4 word, one word is there that is of 32 bit. So we can represent in terms of byte. So we can say like this word, one word is having 4 byte. Okay. So mostly the memories are considered to be byte addressable. In the sense, even if it is of 32 bit, it has 4 bytes. So we can say like B0, B1, B2, B3. So each byte will be having its own address. The address will be represented in terms of byte. Each bit will not be represented by an address. Okay, each bitwise address is not there. That's why mostly the memories are considered to be byte addressable. So byte addressable in the sense each byte will be having its own address. So if suppose the first location is having the address 0000, this is in hexadecimal, then this will be indicated by 0000. This one will be indicated by 0001. This one is 0002. This one is 0003. The next location, there will be a next location. Next location will also be having 4 bytes. So this location will be having 0004. This location will be having 0005, like this. this will be having 0006, and this will be having 0007. This is how the memories are basically represented in byte format. So byte will be having its addresses. So three basic information quantities to deal with the information is bit, byte, and word. So one byte, it is having 8 bit, and word. Word is basically decided by the processor. If a processor is there, that is of 8-bit processor is there. So there one word will be of 8-bit. If a processor is there, that is of 32-bit. So one word will be 32-bit. If a processor is of 64-bit, then the word size will be 64-bit. The word size depends on the type of processor. A byte is always 8-bit, but the word length typically ranges from 16 to 64-bit. That depends on the type of processor. It is impractical to assign distinct addresses to individual bit locations in the memory. Okay, so that's why the most practical assignment is to have successive addresses refer to the successive byte. So based on the byte, the addresses are basically given into the memory locations. So this is the assignment used in most modern computers. So in most modern computers, byte addressability is basically used. The term byte addressable memory is used for this assignment. Is like the byte locations will be given as like 0, 1, 2, 3, 4 likewise. Thus, if the word length of the machine is 32, so word length is 32. In that sense, the successive words are located at address 0, 4, 8 with each word consisting of 4 bytes. So what is the meaning of that is if a memory is there, that is having the different locations. These are the different locations. Then it says like it is having 32-bit. So this is 32-bit. This is the word side. One word is having 32. But the address, how the address is basically defined. So the first word will be having the address 0. Okay. The next word will be having the address 4. How it is 4? Because this is 0 and here it is basically 32-bit, and in that 32-bit there will be 4 bytes. So the first byte will be having the address 0. This one will be having the address 1. This will be having the address 2. This will be having the address 3. Then the next location. This is the next location. This next location will be having the address 4. So if this is the 4 in the sense, inside it, how it will be looking like, it will be here, it will be 4, this will be 5, 6, and 7. Then the next location will be having the address after 7, this will be 8. So the actual address that will be there outside the memory will be like 4, 0, 4, 8, 12 likewise. So it is 0, 4, 8 and likewise. Because each location is having 4 bytes. So it will be each byte in that it will be numbered 0, 1, 2, 3. So based on the byte addressability concept, there is 2 different representation of the addresses. So 2 ways are basically used to byte address different memories. So one is called Big-Endian, another one is called the Little-Endian. How it is different? So you can just think of it here is, if we talk about the Big-Endian and Little-Endian assignment. So this memories, you can just look at it here. If this is the information, so you can see, you can just see here. So Big-Endian used when lower byte addresses are used for more significant byte, leftmost byte of the word. So into a word, suppose a word is there, into a word, this is a word, the Big-Endian used when the lower byte address, So lower byte address are used for the more significant byte. So more significant byte, in the sense this is the word, into that there is a byte. Suppose this is the most significant byte. Suppose this is B3, this is B2, B1, B0. So it says like in Big-Endian assignment, it uses lower byte address. So lower byte address. So into that, this is the address. So into that, this one is the lower byte address are used for the more significant byte. More significant byte into the word. This is the byte. Most significant word is B3. So B3 will be used into the least significant address. Okay. So B3 will be used into the least significant address. Similarly, in the Little-Endian is used when the lower byte address are used for the less significant byte. Less significant byte in the sense rightmost byte. So rightmost byte is B0. So B0 will be used for the lower byte address. So this will be the one. So this is how the Little-Endian and Big-Endian is used. So both assignments are used in commercial machines. So most frequently it is like the Little-Endian is used based on the different processors. It will be using either the Big-Endian or Little-Endian. So most significant and least significant are used in relation to the weight, that is power of 2 assigned to the bits when words represent a number. The labeling of bits within a byte is like B0, yeah, that is from left to right. Okay, so this is how the Big-Endian and the Little-Endian assignment is there for different bytes.